All right, this is another quadratic equation, except this time we have to solve it by using the quadratic formula, which I highlighted in orange, and then over here I have it listed for you. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a when you have a quadratic equation in the form of ax squared plus bx plus c equals 0. And there was a little song, if you can ever remember the quadratic formula, it goes by the tune of Pop Goes the Weasel. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thank you. Thank you very much. Okay, so when you have it in this form, grab my highlighters again. Let's use a brighter color. The a is the coefficient on the x squared. So a, in this case, is equal to a 3. And then it says plus b, but the b is the coefficient on the x to the first. And in this one, we have a minus 5. So, well, that's weird. How does it do that? Hang on. There we go. So b is a negative 5. And then for the c, it's the constant. This is a plus 1. Now, had that been a minus 1, I would have said c is a negative 1. But, and I forgot my equal sign here. Okay, c is equal to a 1. And on this one, sorry. Oh dear. I don't feel like restarting my recording. This is b equals negative 5. Okay, so you go to the quadratic formula, which is right here. And whenever I do this, I always would take out every variable and put in parentheses in its place, because back in my day, I didn't have a whole lot of colors to use. It was all just pencil lead or on the chalkboard. So let's see. Where is the a? Because a is in the green. So here is an a, and here is an a. And then b, I had in the lovely pink color. This is a b, and this is a b. And the c goes right here. So pink, I have a negative 5 here, and a negative 5 there. I have a 3 here, and a 3 there, and a 1 right there. And now I just need to simplify it, okay? So I'll switch to different colors here. If you have a negative of a negative 5, that would be a positive 5. If you take a negative 5 and square it, negative 5 times negative 5 is a positive 25. If you take negative 4 times positive 3 times positive 1, that would be a minus 12. And then in the denominator, you have 2 times 3, that is 6. Now I'm going to switch back to black. Then I'm going to complete what's underneath the radical here. This 25 minus 12, that's what's going to go here. 25 minus 12 is 13, and I cannot simplify that. So that's my answers. There's actually 2 of them. If you split them up, it would be 5 plus the square root of 13 over 6, and then a semicolon, 5 minus the square root of 13 over 6. Mobius said it wanted the answers exact, so let me go back to Mobius. And let's see, enter the exact answers with a semicolon. And is this giving me an option to do anything? Nope. Okay. So to enter the square root, type square root of a. Oh, lordy be. Enclose numerators and denominators in parentheses is not the same as them. Okay, so parentheses, and it is 5 plus, and it said square root of a, so whoops, how did I get that? Oh, forgot to hit shift, sorry. Shift. 5 plus SQRT parenthesis 13. Close that parenthesis and then close the original parenthesis and then backslash backslash. And then since my denominator is just a 6, I shouldn't need that in parentheses. And then put a colon and then parenthesis 5 minus SQRT parenthesis 13, close the parenthesis, close it again, backslash 6. I think I typed that all incorrect. I'm staring at it. Let's click on the how did I do and see what it says. Yay! It liked that. And then of course down here you have to click on this and, you know, type in whatever it is you need to type in, blah, 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 and tell me how you did the problem, which is pretty much what I did right here. So it can be a little tough typing it in, but do the best that you can. You can add in some words in there. That always helps too. So, quadratic formula. Pop goes the weasel. There you go.